break-even analysis. So in this video demonstration, we'll show you how to perform break-even analysis for a linear price demand relationship. However, the process will be exact same for any kind of relationship. For non-linear exponential, we'll show a couple of them in the later video. So you have already seen the price function, the total revenue function, the cost function, the profit function. So if you plot the total revenue and the cost along y-axis and along the x-axis, let's say we plot the demand along the x-axis, demand D. So the total cost function is basically a straight line going up. So this is the total cost, which is the fixed cost plus the variable cost. And variable cost is the per unit production cost times the total demand. Also, the revenue function, let's draw that using another color pen. So it start from 0 and it hit it max and then go down like this. So the total revenue function for a linear price demand relationship is unit price times the demand. Unit price is A minus BD. We have shown that before for a linear price function times the demand. So it's going to be AD minus BD squared. That's the total revenue. Because of the D squared term negative, after hitting it max, it's going to go down. So as you can see, it's going to hit the cost function at two different points. So first, so this point is the total cost is same as total revenue, meaning that profit is 0. So not making profit. Same here too. So the total cost is equal to same as the revenue. So at both of these points, profit is equal to 0. So if you draw the profit curve, it's going to look something like, let's take a purple color. So it's gonna, so if this is 0, 0, so the profit curve is gonna be looking like this for a linear price demand relationship. You're gonna make some profit within this range, and if you produce less than that, let's say this is our D1, the first break-even point, D2 is the second break-even point. So if you produce less than D1, your cost will be more than the revenue. Also, you can produce more than D2, then also again, your cost will be more than the revenue. So you're gonna lose money basically there. So this. So to simply find the break-even points, you just said either profit function is equal to 0. We have shown that before, or the total revenue is equal to total cost. So simply you can do TR is equal to total revenue is equal to total cost. So AD minus BD square is equal to CF plus small c per unit production cost times the demand. And then just rearrange it like something like that quadratic equations. X squared plus bx plus c is equal to 0, so that we can use that formula. X is equal to minus b plus minus b squared minus 4ac divided by 2a. That's what you're going to do here. So simply D, we're going to rearrange that ax squared plus bx plus c form. So this is going to be minus bd squared plus a minus cv, small c, per unit production cost times demand minus the fixed cost is equal to 0. So simply solve for D. So it's going to be minus b. Now in this case, the b is a minus cv. The small cv, of course. Then plus minus square root of b square. Sorry, cv whole square minus 4ac. Our a is minus b, c is minus cf. divide by 2A, our A is minus B. So this is the demand, break-even demand, for which you're not going to earn money or lose money. Using the minus sign here will give you the D1, and then plus sign will give you the D2.